All right, so we're going to talk a little bit more about balancing today. So you guys did the demos yesterday for balancing. We watched the Bill Nye. If you weren't here yesterday, ask your classmates about the demos that they did. They were pretty fun and pretty funny. So first thing we're going to talk about in terms of balancing, and it's something that I mentioned yesterday and something that we said that is different for boys and girls, is the center of mass. And the center of mass is the point of an object where all mass is balanced. So for girls, and in humans, for girls, the center of mass is in their hips. For males, the center of mass is in the middle of their abdomen. And the reason this is because girls have more reproductive organs in their hips, near their hips, and males don't. So center of mass for a human is typically towards the center. Now the center of mass for other objects depends on where all that mass is distributed. So for example, in a ball, the center of mass is right in the middle. In a bowling pin, the center of mass is somewhere in the middle. Now the fulcrum is also known as the pivot point. So the fulcrum is the point at which something can be pushed and it will move over that point. So for example, in like humans, the fulcrum would be in the area where their center of mass is. It's the pivot point where you can pivot over. If you're thinking about a teeter-totter, right? If we think about a teeter-totter, and the teeter-totter looks something like this. Here's our teeter-totter. The fulcrum is the point right here at which this teeter-totter pivots back and forth, back and forth. If we look at this little image right here of this matchstick, this cork, and these two forks balancing on this cup, this right here is the fulcrum, or the pivot point. Now, in order to balance an object at its fulcrum, at its pivot point, we have to use an equation, which is mass on the left times the distance on the left equals mass on the right times the distance on the right, or MLDL equals MRDR. So let's do a little sample problem. Sample problem says Bill balances a broom on a rock. If the bristles of the broom with a mass of 4 grams are 8 meters from the fulcrum, where should Bill sit to keep the broom balanced if he has a mass of 20 grams? So if we were to draw this out, here's our little teeter-totter. And let's say that Bill is on the left. So the bristles of the broom with, let's say the bristles of the broom with a mass of 4 grams are 8 meters from the fulcrum on the left. Where should Bill sit to keep the broom balanced if he has a mass of 20 grams? So let's do this. Let's go 1, 2, 3, 4, 5, 6, 7, 8. You go 1, 2, 3, 4, 5, 6, 7, 8. So if the bristles of the broom are 8 meters, let's say this is 8 meters, and it is 4 grams over here, we need to figure out where Bill needs to sit if he's got a mass of 20 grams. Where is he going to go over here? So I can plug this into my equation. The mass on the left is 4. The distance on the left is 8 equals mass on the right of Bill, which is 20. And the distance on the right, we don't know, so we have to solve. Well, 4 times 8, what does that equal? Excuse me. Equals 20, all right? So you need to solve for these two numbers. So 4 times 8, 32 equals 20 times dr. Well, how do I get dr by itself? I have to divide both sides by 20. And 32 divided by 20 gives us a distance on the right of 1.6 meters. That's my answer. So if I was to draw this, here's 1, here's 2, 1.6 is right here in the middle. So this is 1.6. And what is the mass? The mass is 20 grams. All right, let's do the next example. So this one says 30 grams of paper clips are hanging on the left side of a fulcrum. And the paper clips are 7 centimeters from the fulcrum on the left. How many grams of paper clips should be hung 10 centimeters from the right side of the fulcrum? All right, so let's draw this out. And we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on the left, we have at 7 centimeters, 1, 2, 3, 4, 5, 6, 7 centimeters, we have 30 grams. Now, on the right side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters, we have to figure out the number of grams. Well, let's plug this into our equation. So we have mass on the left of 30, distance on the left is 7. The mass on the right, we don't know. And the distance on the right is 10. Okay, so let's do the math. We have 30 times 7, which is 210, equals mass on the right, times 10. If I divide both sides by 10, divided by 10. 210 divided by 10 gives us a mass on the right of 21 grams of paper clips. So over here, this equals 21 grams. So what you guys are going to do is you are going to not only solve the math, but you are also going to draw your teeter-totters for these types of problems in your worksheets. So I believe on the worksheet that you guys are going to do after you do the FET, you're going to do the FET next. You're going to do the balancing review worksheet. And then for number 4, I have drawn the teeter-totter for you. Number 5, 6, 7, 8, and 9, you have to draw them in yourselves. All right? So the notes, check, you're done. Now you're going to do the FET, then you're going to do the balance review worksheet. Have a good class.